Hi, this is Mr. Mac back again. We come to a place in the notes where you're supposed to try one. So at this particular point, pause the video and read the you try and give it a try. Hi, we're back. Now, we had a random survey of sample voters, and 38% were going to vote for Gonzalez, 31% were going to vote for Chang, and 31% were going to vote for Harris. Now, the survey has a margin of error of plus or minus 3%. Does the survey clearly project the outcome of voting? Well, a couple of questions that pop up into my mind. In other words, is the outcome of the voting just the one that gets the most votes going to win? In other words, is the plurality winner going to win the election? Or are they going to have a runoff of the top two? Well, anyway, whether or not that's the case or not, if we want to know who's going to win this vote to either be in the runoff or if they win by plurality, see, we've got 31% who are going to vote for Chang. No, let's see. 38% are going to vote for Gonzalez. So we have 38 plus or minus 3%. So that would be somewhere between 35% to 41% would be voting for Gonzalez. I'll just put G. And Chang and Harris both have 31%. So we'll just do Chang or Harris. We have 31%, and again, that's plus or minus 3%. So that would be 28% to 34%. So there is no overlap of percentages here. It looks like Gonzalez will be the winner of the plurality here. But again, let me remind you that this is probably a 95% confidence interval. So 5% of the time, it could even be outside of that. But truthfully, as a person who has experienced these polls, if this poll is accurate, Chang and Harris don't have much of a chance. All right. A study is performed at the local college to determine the average GPA one semester. A random sample of students' grades are taken and determine the sample mean. The X bar, which is a symbol for average, is 2.7. And it's decided to use this value to estimate the mean of the population. Is it possible to estimate the value of 2.7 as the actual GPA for all students taking class that semester? Now, we got some things to consider. X bar will often be somewhat different from U. There's no way of knowing how close the sample mean is to the population mean without obtaining data from every individual. This can be very impractical and sometimes impossible. To account for this, statisticians prefer using an estimate that contains an interval, and usually these are confidence intervals. Now, below is a list of values. So what we do is our level of confidence. If we want a level of confidence of 90%, then we're going to use a z-value of 1.645. If we want a 95% confidence interval, we're going to use 1.96. And if we want a 99% interval, we're going to use 2.58. Now, what we do is we make a confidence interval, and notice here, I'm just going to make my own little arrow. Notice here that we start by using the population statistic, and then what we do is we say, all right, it's going to be plus or minus the z-value of the level with which we want to be confident, either 1.645, 1.96, or 2.58, and then we'll multiply that by the standard deviation and divide by the square root of how many we surveyed. Now, as you can see, if the number that we survey, n, increases, then this whole quantity here is going to get smaller and smaller. As n gets bigger and bigger in the denominator, this thing gets smaller and smaller. So if you want a smaller interval for your percentage of confidence, then what you do is you increase your sample size. So here are the steps. Step one, calculate the margin of error using the z-value of the confidence level. 2, subtract the margin of error to get the lower limit of the interval. 3, add the margin of error to get the upper limit, and use this formula. Let's see. To use this formula, the variable must be normally distributed or have a sample size of n greater than 30, and the sample should be less than 10% of the population. All right, now let's go. Ooh, what on earth was that? Let's go play. We've got a random sample of birth weights of 186 babies, has a mean of 3,103 grams and a standard deviation of 696 grams. These babies were born to mothers who did not use cocaine during their pregnancies. What is the well, I mean, okay, you laugh at that a little bit, but that would be a confounding factor. In other words, if you had a sample, and some had used cocaine and some hadn't, I've heard, although I'm not a doctor or have not done any extensive study on this, but I've heard that babies from mothers who have used cocaine are generally much smaller and much more challenged in surviving after they're born. So what they're saying here is that these babies were all born to what would be considered fairly healthy type mothers and should be fairly healthy themselves. It says construct a 95% confidence interval to estimate the mean birth of weight for all such babies. All right, now if we want to be 95% confident, then we're going to take the mean weight, which is 3,103 grams, and to that we're going to add or subtract. Now, since it says 95%, we're going to use 1.96. 1.96 times the standard deviation. Did they give the standard deviation? Yes, 696. And then divided by the square root of the sample size, which was 186. Now, as you can see, this one definitely requires a calculator. So, 3103, and let's do minus first. Minus 1.96 times 696 divide square root 186. And let's just look at the formula, make sure I didn't mispress any buttons. 3103 minus 1.96 times 696 divided by the square root of 186. That looks good to me. So I'm going to press enter, and I get 3,003 grams. So I'm just going to put 3,003 on the low end. Now, here's something else. If you're using one of these graphing calculators, and you've done this all in one step, watch what you can do. If I press the second button and then press enter, this thing comes back on the screen, and the only thing I want to change, I press the up arrow, the only one to change is that minus to a plus, and then I can press enter again, and it gives me 3,203, so 3,203 grams. So a 95% confidence interval is that baby weights to healthy mothers, we'll say, have a mean, we're 95% confident that the mean of all of those babies is somewhere between 3,003 to 3,203 grams. Now, it says find the critical value. I'm not quite sure. Oh, I guess the critical value here is the 1.96 because of the 95%. Let's just go back and check to make sure that that's the way it was presented. See, in the table, where was that table? There it is. In the table, they did call the 1.96 the critical Z value. So the critical value was 1.96. The margin of error was, actually the margin of error would be all of this multiplied together. Let's go ahead and find that. We can get that from our calculator pretty easily too. So let's get that. I'm going to press second enter But now what I'm going to do is I'm going to go back and I'm going to delete the 3,103 and just calculate the part that I've circled here. That will be 100.02. So the margin of error is plus or minus 100 grams. And calculate the confidence interval. That's this part right there. Okay, now interpret the interval. We are 95% confident that the true value of the population mean weight of all babies born to mothers who do not use cocaine is between 3,002 and 3,204. Well, I'm off on that by 1 point. I don't know what happened, but I'm conceited enough to believe I like my value better. I mean, when you go through it, if you found that I've made a mistake, let me know, but I think I'm right. Okay, I'm going to stop there and start another video for the rest of it.